Happy New Year, 4J! Welcome back! We are on our first virtual field trip of 2021 to the Eugene Science Center. It's right behind me. In a moment, we get to go inside and explore the space and see all they have to offer. Thank you for joining me today, and let's go head on inside. So we got a little detoured on our way back in. You'll see this little guy right here. He is a baby nutria, and there are actually more of them right here. And nutria are actually an invasive species. They do not belong. Invasive means that they are not native to Oregon or actually even North America. They kind of look like a cross between a beaver and a big rat. But there's a mama and her babies, and I thought I would just show you, because even though they're invasive and they don't belong here, they are kind of cute. Let's see how close we can get. We're right on our path. Well, here we are inside the Science Center, and I am with Karen, our guide, who's going to walk us around and show us the exhibits. And she's going to talk us through what we're going to learn about as we visit these exhibits today. And then we might be able to end with a little surprise as well. So let's follow Karen around and have a tour of these exhibits.
Awesome. Welcome, guys. So we're going to start just right over here. I want to show you guys some of our collections. So in this display here, we have all different kinds of fossils. So fossils show us a record of things that used to live a long time ago. So we have a really great collection here, and you're welcome to come get a little bit closer if you want to come up. And then right next to them here, we have some insects and arachnids that we have.
Those
on
are
display.
so cool.
Yeah.
So are these, like, those are fossils, right? So
Right,
those
so
you found somewhere, or how did you get those?
These were donated, so these are specimens that used to be alive and they were preserved for display. So they are different types of insects and arachnids from all over the world. So we've got some of these really big insects here, the phasmids.
Where would we find these?
In Australia. So
Yes.
usually if it's a big scary bug, it's probably from Australia.
I've been to Australia and things there are huge.
Yes.
Yes. Oh my gosh, fascinating. And where's this giant scorpion found?
I'm not sure. That honestly could be from North America. I'm not sure exactly where
I ran into scorpions. Well, I've seen them in southern United States, but also when I was in South America a lot.
Wow.
Yeah. Wow, these are, and the golden orb spider is also in Australia, right? Huge spiders. Yes.
Big guys.
Those are
Yeah.
awesome. Cool.
All right, and then we can move over here. This is one of my favorite exhibits. So this is an interactive sand table where we can learn about topography. So topography is a type of map making where you can see how high land is. And I'm not sure if you'll be able to get a picture of this. Oh, it looks like we've got a little bit. But you can see that.
It shows that. That's awesome.
But as we build a mountain here, we can see the colors changing and we can see these lines forming. So each line is a measurement of elevation. So we're getting higher. So this is a really fun thing to play with if you like to explore with maps. And we've got an example here of the Grand Canyon, of what a topographic map for them looks like.
That is cool. So it just changes. So I could turn this into like a lake right here. If I dig deep enough, there's my lake.
Yeah.
Whoa, that is awesome. And there's the lines for the depth. That is a very, you could spend a lot of time here.
Yep, it is certainly one of my favorites.
That is cool.
And then right behind us here, I'm going to challenge you to build your own satellite, your own spacecraft.
My own satellite?
Yes, so
Oh
you
my
can
gosh.
use any of the pieces here. You want your satellite to have an energy source, a way of communicating with us back on Earth, a way of navigating.
So is this like a solar panel?
Yes.
Okay.
And then you want it to also have a way of collecting information. So we have
got it.
that's
Okay.
right, all these different things, and then you can
There's the
test
key.
it and see if it would actually survive over here at our test station.
Okay. I'll be quick, guys. See, I wish you were here with me so you could tell me what to build. how to build these.
Mm-hmm.
I'm gonna.
Yep. So your satellite or your spacecraft could get its power from the sun. It could have a solar panel, or it could generate its own power using a nuclear generator, which is.
Is that one of these off? Oh, the nuclear generator is right there.
Yeah, it might be on the other side here.
I really like solar energy though, so I'm gonna put this right there. And then
so your satellite could be in outer space collecting pictures of things that it sees and then sending them back to Earth.
Look it, there's my skills. Yep.
All
and
right.
I really like that it's got a hole right here.
Well, if you'd like to test it, you can strap it in.
Okay. Okay, strapped in.
And you can give it a spin.
Oh gosh. Spin like this?
This one.
Oh, this. Oh, look at that.
Looks like it could handle some rotational velocity. And if you wanted to test it for vibrations, you could then
strap it
into
oh,
a
and then
shake table.
Shake it. Okay.
Shakes it. And it looks like you did a good job here. You've got your power source, your communication device, your navigation tool, and your camera, your science collector. So you did a good job building it.
It's my second job, you guys. Look at it's even. I lost my solar, my camera. Darn it. I need your help. You guys have to come here and show me how you do it.
Mm-hmm.
Okay, that was fun.
Yeah, and then right behind us here, I'll show you what's in this display. So here on the bottom, these are actually projects that kids who live in Eugene and Springfield made. Every year we work with the National Association of Women in Construction to hold a competition called Block Kids. And kids are in a challenge where they use Legos to try to build something in a set amount of time, and then they compete.
That's awesome.
So these projects that are on the bottom here were made by local students, and these are our first through third place winners here.
That's cool.
So if you like to compete with engineering and building, you could definitely join us for Block Kids back when things are back to normal. That usually takes place in February. Fun. And then over here we can explore different ways that satellites collect visible information, even if it looks invisible to our eyes, using different tools. So in all of these different ways of looking at something, we can test some of these pieces. So what you're gonna do is pick up one of these blocks and you can stick it under the infrared light there and see if anything shows up that you don't see on the block itself.
Okay, guys, so this is the block normally, and then when we put it under here, look at what we see.
So that camera's looking at infrared light, so it's showing us a picture that our eyes can't see, but using infrared light we can. So there are satellites in outer space that look for infrared light, and it's not visible to the human eye without special tools. And then over here we have magnification. So we could see, you're gonna just slide it in here and see if you can find something. I'll let you do that. Might be a little hard to catch on film.
So I look in here.
Yep, so you'll look through here. And you might have to slide it around and see if you find anything.
Oh, yeah. Oh, little tiny. So it's magnified, guys. So there is little tiny writing right here. And when we put it in here, I don't know if you can see that.
You can if you did the right angle.
Yeah, nice job.
So there's some
You
writing
can
on
see
there.
the magnified words. Nice job, videographer. Nice.
Yeah. And then over here we have our ultraviolet light sensor. So you could see right here that we just see some black and white, and see if anything shows up when you turn on your ultraviolet light.
Ooh, do you see that? Without it, with it.
Yeah.
Ultraviolet light. That's cool.
And then here we have a detection for magnetic fields. So you can kind of slide it up under.
Oh.
So yep, hidden inside of that block are some magnets that we wouldn't know were there unless we were looking for a magnetic field.
Okay.
So, yeah.
Cool.
So this is showing us something called a needle in a haystack. So you're gonna spin this and see if you can find the red bead. So I'll let you look for the red bead.
Okay, guys. Do you see it? Oh, I saw it. Do you see it? It's right there.
So that tiny little dot represents the piece of outer space that we have actually seen. So all the rest of it is unexplored to us.
Oh my goodness, look at all of that unexplored space.
Yeah.
That's not even just the Earth. That's like just all the stuff that we see, right?
Mm-hmm.
Wow. Okay.
All right, and
Big.
then, yeah, over here we can visit our Bernoulli blower. So here you're going to want to grab this.
Okay.
And I'm going to turn this on. And you're going to see if you can get it to float.
If I can get it to float.
Mhm.
Whoa! Look at that magic! Woohoo! That's awesome.
So the reason this is called a Bernoulli blower is Bernoulli is the name of the scientific principle that explains how air can keep this ball in place. And you can actually try to move it around a little bit and see if the ball will stay. You can try to wiggle this.
Oh, got it. Oh, look at that! That's
This is
cool.
another favorite for kids to play with. So I hope you guys get to come explore with this.
Yes,
back
you
when
guys
we're
need to come
open.
here. Look at that. Woo! I'm happy to have fun for you.
So this is our engineering wall. So all of these pieces here you can move around and build a track, and then we're going to shoot balls up into the top and have them fall down, and you can build a track that catches the balls. So I over here have the control for our fan. So there's a fan that's going to blow air up through this tube, and it's going to suck these balls up, and they're going to come down. Go ahead and put some in here.
Oh, I see.
So the goal is to build a track that can catch the balls. So you can try moving pieces around, see if you can build a track. Oh, that one went way over there.
Oh, there it goes. Right in your way.
Oh, nice. Oh, we got the green one to go all the way through.
Nice.
So in each of these tubes is tiny little bits of metal. And we can take these magnets and move the metal around.
Oh, they look like little creepy blobs. Well, that one's going high. Whoa, I got a little separate guy. It looks like a sea urchin.
Yeah, so we have
cool.
different sizes. So the little bits of metal in here are slightly bigger than the ones that were in the one you were just playing with. And then in this tube, this is the most fun one. These are the teeny tiniest bits of metal. They are nano-sized.
And that's metal in there that's acting like a liquid?
Yep, it's a ferrofluid. So it's a fluid made of bits of metal that are so tiny they act like a fluid. You can engineer a wind turbine. So these pieces here, you can move around, so you can change them up if you want. And the goal is to build a turbine that will spin when air is passing through it. So if you want, you can try building your own. Going in one direction. So
Look at her. Look at how. Oh my gosh, mine's not even blowing.
And then over here we can measure how fast it's going.
Oh, mine is not.
But all engineers learn from failure. So
That's right.
you can't
Of course.
succeed without failure first. There are different
Oh my gosh,
colors.
look at there are 3 of me. A
Mhm.
yellow, a purple, and a blue.
So with this, you can experiment with mixing different colors in your shadow and see how your shadow moves as you
Oh.
are closer or further from the wall. See if. Yeah. See
Look
what
at,
happens.
so when my purple goes over into, or a pink goes over into blue, becomes more purpley. And then I got, oh, I see, so you're like learning how to blend colors. I'm really close. Look at how bright they are when I'm really close. Move farther apart.
Look into this camera, we're seeing all different colors, but they're not the colors that we're seeing with our eyes. So this camera is showing us heat. So we are looking at how hot or cold something is. The carpet here is blue, the walls are blue, so our bodies, and I can see as I'm talking that I'm getting more heat coming out, our bodies are going to be the hottest parts. You can see our faces are shining, we're like bright yellow.
Yeah.
So here we're seeing all the different types of heat around us, and we can actually create heat. It's pretty fun. We can use friction to draw on the floor.
Oh,
So that's one of my favorite things.
Cool.
And then right here, this is our newest exhibit. It's actually a prototype right now. So we are designing an earthquake station. So your job is to build something that could survive an earthquake. So we have all these tools here to build with, so we can do this together. Do you want to test your structure?
Yep, absolutely.
All right, so over here you're gonna hit the on switch. So you'll flip that over. And then I'm gonna start this low. So you can hit that green button, and then as you turn the knob, you can change the intensity of your earthquake.
Okay. Oh, look at that. That's not so good. My top is falling. Getting worse.
Oh, mine totally fell apart. Yours is doing great.
Hey, it's still managing. Oh, my foundation. It can't handle a full-on earthquake.
Yeah, a big earthquake, it might not survive. So
That's fun. I love that.
So if you're at home and you have blocks, you could try to build something like this. If you had a board, you could put it on top of something like tennis balls and shake it around on top of the tennis balls. It's pretty fun.
Yeah, that's a great idea.
And then over here, I'll just turn this on for you guys.
Oh,
This is our gravitram. So it's gonna send balls along these tracks here. This is a fun one to just kind of sit and relax and watch.
Yes.
There's several different tracks that the balls travel down. And sometimes they need a different track to be activated in order to move forward.
That's cool. So, is there something that decides which track it's going to go down, like a way that it comes off the track, or does it just take turns going different directions?
So part of it is, if you look right up at the top there,
Yes.
there is a little switch that goes up and down, a lever. And so sometimes the balls go up,
Oh, I see. So then the next one's going to go underneath.
and then the next one goes under and it's going to hit it back up. And then there's a couple different switches like that along the way.
Got it.
So yeah, this is a very old exhibit.
I've
that
been
has survived
here
long
for a
time.
long time. Yeah. That's cool.
So your parents may have seen it when they were kids. All right. And then over here we have some nice minerals. So in this shelf here, we can see that some of these minerals are glowing or fluorescing. So they're under a black light. So we can see that this one right here, you can probably see on the camera, is glowing bright green. If we were looking at it with just our eyes, it would not look like that. But we can get an idea of what it looks like under ultraviolet light, which is pretty cool. But we have all different types of rocks and minerals that were donated to us. And next door here we have some skeleton replicas. So we have a coyote, and we have a beaver and a nutria. And I know you guys just saw some nutria outside when you were out in the park. So we have a few different types of rodents that live near our waterways here, and usually if we're out and we see a little furry brown animal near the water, it's probably a nutria, which is an invasive species. It's not native to Oregon, but they are a bit less shy than beavers. So I know that beavers are around. They've been chewing on tree branches and building things, but I have never actually seen a beaver out in the park. They are much more shy, where nutria we see just about every day. But the beaver here, quite a bit bigger. We can go ahead and transition to our next surprise.
Great. All right, so here we are in our surprise. We're in the planetarium, and it's daytime. I'm gonna let Karen explain what's going on, what we're seeing.
Yeah, so we are right now on planet Earth, and I am going to take us off into outer space so we can get an outside view of the Earth, and then we'll take a look at the stars and hopefully go visit the moon. So get ready. I'm gonna actually, let's see. Whoop. Oh.
Whoa!
But that worked. so we can see where we are here in North America. I am gonna zoom out. And right behind it, you can see that big stripe in the sky is the Milky Way galaxy. So that is the galaxy that we are in, and that is so many stars all clustered together, making it really, really bright. And I hope that this is showing up on your computers at home. I'm gonna zoom away from our planet here.
Whoa.
All right, and I'm gonna take us to the moon. All right, so we're narrowing in on the moon here. It's gonna be right up top.
I see it.
And then we're gonna fly right to it.
Oh my gosh, there it comes. Check it out, there's the moon.
So we should be able to see some of the dark and lighter spots on the moon. So if you have ever looked up at the night sky, you have probably seen the moon before. I hope you guys get a chance to look at it tonight. So the cool thing about the moon is that the craters don't go away. There's not anything to cover them up. There's no wind. So those craters are kind of like a history book of what has happened on the moon. And then in the distance behind the moon, you can actually see the planet Earth that looks like a moon now. So I'm noticing that the moon looks like it's disappearing. We're going to the dark side of the moon. This is the side of the moon that's in shadow. And if you see that bright light, that's actually a star, that's our sun. And because of the angle of the light coming from the sun, it's kind of right over by the line of the Milky Way galaxy there, we are in shadow on the moon. But if I turn us around, we should be able to get back to the light side of the moon as we get closer to the side that is facing the sun. Let's go to Mars. Let's see if it'll go to Mars. All right, so we are headed to the planet Mars.
Whoa.
Okay.
Awesome. Now, how long would it take us to get there if we were going by spaceship?
A very, very, very long time.
Like years, right?
Yes, years and years. And there are actually NASA missions headed to Mars, which is super cool. Take us back out into the solar system and we can...
Awesome. Thank you so much. This has been awesome. Thank you for joining us, 4J. I will see you next week.